Hello everyone, my name is Lily, and for my final project for the course, I've decided to look into a comparative analysis of hurricane-induced vegetation damage in Tampa Bay using remote sensing. So to start off, it's important to remember what hurricanes are. So if you're from Florida, you're probably quite familiar, but in the context of damage, hurricanes can cause widespread vegetation damage with wind, flooding, and saltwater intrusion. Monitoring these impacts is important for understanding ecosystem resilience and recovery in coastal regions like Tampa Bay, where I'm from. So, with this project, I'm attempting to analyze and compare vegetation damage caused by two different hurricanes, Hurricane Irma and Hurricane Ian, using Sentinels to satellite imagery. The objective is to quantify and map vegetation change using NDVI-based differencing to identify areas of no change, moderate loss, and severe damage. So, looking at the two hurricanes, Hurricane Irma hit the ground in 2017, and Hurricane Ian hit Florida in 2022. Hurricane Irma made landfall in Florida as a Category 4 storm and then weakened as it moved northward, bringing strong winds, heavy rainfall, and widespread flooding. In contrast, Hurricane Ian struck the Gulf Coast as a high-end Category 4 storm, producing extreme storm surge, prolonged inundation, and severe wind damage, making it one of the most destructive hurricanes in recent history. So, in looking into the project itself, I used Google Earth Engine and Sentinel-2 satellite imagery to analyze the vegetation change caused by these two hurricanes in the Tampa Bay area. My study was focused and defined using county boundaries for Hillsborough, Pinellas, and Pasco counties. The images were selected for time periods before and after each storm, filtered by date, location, and cloud cover, and a cloud mask was applied to get rid of the cloudy pixels, and then composite images were created to represent the pre and post storm conditions. The NDVI index was calculating using the red and near red infrared bands to measure vegetation health. Vegetation change was then determined by subtracting pre storm NDVI from post storm NDVI, and then negative values indicated vegetation loss, while the values near zero indicated little or no change. The results were then simplified by classifying the NDVI change into three categories: low, moderate, severe, and then finally, the extent of each damage category was calculated within the study area, and then the results were mapped and exported for analysis. So, when looking at the damage caused by Hurricane Ian as well as the change, the NDVI maps show clear spatial differences in the vegetation condition before and after for both hurricanes. Um, so, when we're looking at Hurricane Ian, the NDVI difference analysis indicates widespread vegetation loss, particularly along the coastal regions where storm surge was probably the culprit in causing severe damage. The inland areas had some patchy declines in the NDVI, so that could have been attributed to localized flooding and agricultural impacts. And then the classification map highlights these patterns, with severe damage concentrated near the coastline and the moderate impacts were sort of dispersed throughout the area. Some observed seasonal changes also may be reflected in like vegetation growth dynamics and compositing effects rather than just hurricane damage, which is important to keep in mind. And then when we look at Hurricane Irma, our data is a little patchier. The NDVI change analysis for Irma was a little bit more spatially heterogeneous compared to Hurricane Ian. While the areas of significant vegetation loss are evident along the coastline and around the inland water bodies, probably again because of flooding and also maybe wind damage. There's also widespread vegetation increase throughout the inland regions. So post storm rainfall could have promoted vegetation recovery or growth, but also, considering the timeline, this could just be natural recovery, especially when areas impacted are agricultural or heavily vegetated landscapes. So as a result, our map is a little patchy with the distribution of moderate and severe damage, reflecting, both disturbance and recovery occurring simultaneously. So when we're thinking about why we can use, or what the point of using NDVI-based analysis for this specific application, we saw that there were differences in the vegetation response between Hurricane Irma and Hurricane Ian. Hurricane Ian had a more spatially coherent pattern of vegetation loss with severe damage concentrated along coastal areas and extending inland in patches, which probably could be because of storm surge and prolonged flooding. Where in contrast, Hurricane Irma had a more heterogeneous pattern with significant vegetation loss and widespread areas of increased NDVI, which could suggest that in addition to damage from wind and flooding, the post-storm rainfall could have promoted growth. as I said. So because of that, Irma's impact looks a little bit more mixed, while Ian's demonstrates a clear and more concentrated signal of damage. So these differences highlight how storm characteristics and timing influence the vegetation response, as well as the limitations of NDVI in distinguishing between disturbance and short term regrowth. So these differences in data quality between events reflect not only storm intensity, but can also reflect post storm atmospheric conditions. Springboarding off of that, there can be influence on the reliability of the remote sensing data because of the different atmospheric conditions and satellite data availability based on these storms. So we work with what we have, but it's always good to keep that in mind. And kind of just looking at the application, this NDVI based hurricane impact analysis is important because it can provide us with a rapid, spatially detailed, and objective way to measure vegetation damage across the Tampa Bay area following major storms, which is really, really essential. So instead of relying just on field surveys, which can be time consuming and really limited to what emergency responders are able to take data on, satellite based change can allow for some consistent comparison of ecosystem conditions before and after a hurricane, which can help identify areas that experience the most severe vegetation loss, highlight patterns of vulnerability across coastal and inland environments, and give us good perspective on what areas need love, what areas need attention, and what areas specifically and especially ecologically might need scientific investment. So, in the future, this type of analysis can support disaster response and recovery planning by helping agencies to prioritize damaged areas, improve resilience strategies, and guide restoration efforts. And it can also be used for long term ecosystem monitoring, like tracking wetland, forest recovery, etc., etc. In addition, it can also help us with our climate research by enabling comparisons of storm impacts over time and contributing to how studies on hurricane intensity may be affecting vegetation more severely. Thank you so much, everybody, for listening, and I hope you have a great rest of your semester.